Hey there students, today we've got some solutions to the practice test for the upcoming topic test this week. In terms of what's actually going to be on this, we've got area and perimeter of shapes involving circles, we've got some volume of prisms and cylinders, we've got a bit of solving equations and a little bit of work on linear graphs as well. As per the last couple of tests, you're allowed to use a calculator for the whole thing. You're also allowed a page of notes, so if any of the examples that we go over resonate with you in any sort of way, feel free to add those to your notes or any examples that you might find useful, any formulas, that kind of thing. As per previous videos, there's time codes in the description so you can jump to whatever question you need help with. All right, let's begin, shall we? The first question is all about finding the area of circles. So nice, easy one to kick things off. We find the area of circles using this formula. We take pi and multiply it by the radius of the circle squared. So let's do the ones that are just here below us. So for this circle, remember that the radius is the distance between the center and the edge of the circle. So for this one, it's given. It's nice and easy. So the radius there is 3. So we'll find the area by doing pi times 3 squared. Now on your calculators, you might have to hit shift like I am just here. But pi times 3 squared should give you 28.27. It's area, so our units are going to be centimeters squared. Right, next question. Pretty much the same thing again. The radius for this one is also given, it's 3.4, so the area is going to be pi times 3.4 squared, and I'll plonk that in my calculator again, times 3.4 squared, and that should be, okay, there's a little bit of rounding to do with this one because we're going to 2 decimal places. We want 36.32, because I'm going to look at that second decimal place. The digit after it is 6, it's greater than 5, so I need to round that 1 up to a 2. Same deal for this one though, centimeters squared are our units. Now this next one, we want the radius for finding the area of a circle, but in this example we've been, oh, something went a bit strange there, nothing that we can't scroll back up to though. This one's a little bit different. This time we got given the diameter, which is the distance across the whole circle. We want half of that, which is the radius. So for this one, I'm going to need to take that 8 and half it and do pi times 4 squared. And I'll put that in my calculator again. And that should give you 50.27 centimeters cubed. And just on your calculator as well, just make sure that you're comfortable using your own calculator in the lead up to the test. If you need to borrow one on the day, that's not the worst thing in the world. But if you don't know how to use the calculator that you've borrowed, it can't really help you during the test. So if you've got your own and you know how to use it, that's obviously a lot better. Next one, calculating the circumference of circles. So there's 2 ways that we can find the circumference. We can do pi times the diameter, or if we're given radius, we can do 2 lots or 2 times pi times the radius. Either of those is fine. And the reason that we have to double it for the radius is because it's half the length of the diameter. So for this first one, we need we want the circumference. We're given the radius, so we'll use the formula 2 times pi times 3. On the calculator, 2 times pi times 3 should give you 18.85 centimeters this time. There are our units for this one. Next one, we're given the radius again for the second one, so the formula we'll use is 2 times pi times the radius. The radius is 3.4, and then on your calculator, 2 times pi times 3.4. So 21.36. Then for the next one, we're given the diameter, so we can just go pi times the diameter, which is 8 for that one. And on the calculator, pi times 8 gives us 25.13 centimeters. Woohoo! Hopefully a nice easy start for everyone. Okay, question 2. These get a little bit harder. So we're going to find the perimeter of the shapes below. So that word circumference that we just did, that means the perimeter of a circle. It's a special word for perimeter of circles. But for these shapes, these are made of part circles, but they're not circles exactly. So we're back to using perimeter for these ones. Okay, now for the perimeter of this first shape, we've got a straight line that's 10 centimeters long. But then we've also got a curvy bit that we need to add on as well. So we need the lengths of both of those to find the perimeter of the whole shape. Now, for the straight line here, that's nice and easy. That's 10 centimeters. Maybe I'll do a little bit of highlighting to make this a bit nicer. So yeah, that length there is going to be given by the measurement in the diagram. So that's hopefully nice and easy. But for the curved component, it's a little bit more tricky. So we've got a nice curved bit there, but what we need to do there is say, okay, well, finding the perimeter of a shape, that is half of a circle with a diameter of 10 centimeters. So what I could do is say, well, the formula for circumference of a circle is pi times the diameter, so pi times 10. And that would give me the circumference of a whole circle with a diameter of 10 centimeters. But we don't have a whole circle, we've got a half circle this time. So we need to take that and divide it by 2, because it's half a circle, right? Then adding those two together, if I do my yellow bit and my green bit is going to give me the length of the curvy part, and then that yellow straight part was already labeled in the question, so that one was really easy for us. So on your calculator, the way you enter this is say 10 plus, and then we want pi times 10 divided by 2. And that gives us 25.71 centimeters. And look, if you check that for reasonableness as well, you've got a length here of 10. That's going to be more than 10, but not like heaps more. So adding on another 15, that sounds about right to me. Now the second shape is a little bit harder. We've got a rectangle with a quarter circle stuck on the end of it. So we've got a few different lengths that we need to find. If we look at our straight edges first, we've got 3 meters just here. We've got another 2 meters just there, and that's going to be the same as the radius of the quarter circle just there. But then for our third straight line just there, we've got to do something a little bit clever. We've got to notice that we've got 3 meters that's opposite the 3 meters on the right hand side, but we've also got 2 meters down the bottom here that's going to be the same as the radius of the circle. This is what makes this one a little bit harder than the one that we just did. So if you're finding the length of the whole thing, that's 2 plus 3, which gives us 5 meters between there and there. Okay, so if we were doing the perimeter of this shape, we've got our 3 straight edges. So we've got the 5 on the left, we've got the 2 along the top, and we've got the 3 on the right hand side. So let's do a bit of a highlight on that. Let's say that all of those we've already done. So we've done straight line here, and straight line here. And that's all of those ones there. But what we have to add on to that is the length of the curved bit at the bottom. So what we think there is, well, that's part of a circle that has a radius of 2 meters. So now I think, okay, well, my formula for circumference is 2 times pi times the radius, which for this circle is 2. But I'm going to have to divide that by 4 because that's a quarter of a circle. So I'm going to need to take what would have been the answer for a whole circle and divide it by 4 because I only have that quarter. I only have 25% of what we started with. Okay, but now we've done our 3 straight edges, we've done our curved bit as well. Now if we put that in our calculator, we've got 5 plus 2 plus 3, and we want to add on to that 2 times pi times 2 divided by 4, which should give us the right answer, in this case 13.14 centimeters. Wonderful. Okay, let's just check that for reasonableness. We had 10 centimeters just from the straight bits, and then a little bit more for the curved part. That seems about right to me. Okay, let's continue. Question 3. A square of side length 10 centimeters has a hole in the middle. Oh no! The diameter of the hole is 5 centimeters. Draw a diagram to represent this situation. Cool. We've got a square. They have side lengths of 10 centimeters each. I might just do that to show that they're all the same. And the diameter of the hole in the middle Just done that weird thing again. Go away, keyboard. Diameter of the hole in the middle is 5 centimeters. If you're running out of space, doing like an arrow or something is fine. Oh, 5 updates available. That's exciting. No, the next question is, what is the area remaining? So we want to take, the way that we do that is that we've got to think of it in terms of what shape we started with. Area remaining. It's going to be equal to the area of a square, but taking away the area of the circle that's missing, the hole in the middle. So the area of the square is going to be given by 10 times 10. And then we're going to take away the area of the circle. But we've got to be a little bit careful here because we've been given that 5 centimeters that we've been given is the diameter of the circle. So that area of that circle is going to be given by pi times the radius, which is half the diameter, so 2.5 to the power 2. So yeah, that's what makes this one a bit of a harder one. 10 times 10, which is 100, take away pi times 2.5 squared, gives us 80.3. Oh, we need to do our answer to the nearest whole number, so that would be 80 centimeters squared. Cool. How good is that? Let's continue. Okay, all right, so that's all the area and perimeter questions, I'm pretty sure. And now we're on to a bit of volume. All right, volume of a prism or of a cylinder is given by the area of the cross-section, which is whatever shape. When we think about prisms, we think, okay, we've got a shape that has the same cross section all the way through, kind of like a Toblerone. It's got that triangle going all the way through. We want to find the area of that shape and then multiply it by the height. Now, the height isn't literally how tall the shape is. It's just whatever other dimension we're working towards for whatever shape that you're given. So sometimes it will be how tall it is, but just think of it as being in whatever direction the cross section is moving. We want to take that length. Now that's the thing that makes rectangular prisms really easy, because you can pick any of them as the cross section. But we think of it this way. Let's say that face is our cross section. Area of that is going to be given by 3 times 2 from the diagram. Now we want to multiply that by the height of the shape. Again, not literally how tall it is, which for this shape is going to be 6 centimeters. So 3 times 2 is 6, 6 times 6 is 36, and now we're doing our units for volume, so centimeters cubed. Okay, let's move on to the second shape. All right, for our second shape, it's this triangle that's our cross-section. So the volume of it is going to be given by the area of that cross-section, which for triangles, we find the area of triangles by doing base times height divided by 2. And then we want to multiply that by the height of the shape, which for this one is going to be 10 centimeters. So multiply that by 10. 8 times 5 divided by 2 is 20, and 20 times 10 is 200 centimeters cubed. And you can check it on your calculator just to make sure you're not having a little moment. Yeah, very good. Always worth checking, even if you're pretty sure. All right, and then for cylinders, the area of the cross-section is going to be given by the area of a circle. So let's say volume, area of the cross-section is going to be given by pi times the radius squared. Then we want to multiply that by the height of the shape, which is 10 for this particular shape. And then in the calculator, pi times 5 squared times 10 gives us, what are we rounding to for this one? Let's go nearest whole number, 785 meters in this case. That's a big cylinder, meters cubed. Wicked. So yeah, for volume, just figure out what your cross section is, find the area of that, and then multiply it through by the height of the shape. Right, let's keep going. We're motoring along. Okay, this is a harder one. So for this shape, let's write the formula to begin with. So volume of that shape is going to be given by the area of the cross section times the height. So we want to find the internal volume of the chest, and we're ignoring the thickness of the wall. So it's the space that's contained inside that chest. But for this one, the area of the cross section is made up of a rectangle with a semicircle added onto it. So we've got to add a couple of things together to give us the area of the cross section this time. So that area is going to be, well, let's do the rectangle first because that's probably a little bit easier. That's going to be given by the base of the triangle times the height of the triangle, so 52 times 27. So 52 times 27. And then we're going to have to add on to that the area of that semicircle just here. Now, area of a circle is given by pi r squared. So we need the radius, which is going to be half of the diameter that's given. So with your circles, always just check, have I been given the radius or the diameter for this? Do I need to half it? Do I need to do anything else? Anyway, so half of 52 is 26. So that's going to be given by pi times 26 squared. And I need half of that because it's a semicircle, right? And then those two added together is going to give us the area of the full face. And beyond that, we just need to multiply it by the height of the shape, which is 95. I'm running out of room. Oh no, I'm not too bad actually. Times 95. Right, so on your calculator, you'll need to use brackets a little bit for this one. So I'm going to go bracket 52 times 27 plus pi times 26 squared divided by 2. Close my bracket. So then the result of those two things added together, I'm going to multiply by 95. Should be a reasonably big number. Yeah, right. That is 234,000 and then 257 centimeters cubed. I'll go nearest whole number again because we've got 6 significant figures there. We could probably have done to 3 significant figures, but I think that's fine for this question because it doesn't stipulate either way. Right, we are done with volume so soon, I know, and now we are on to solving. Okay, the solving one-step equations are kind of like the accessible questions on there. So hopefully relatively easy marks. Coffee break. Okay, now when you see that word solve in a question, it means that your answer needs to be A equals something or B equals something. Whatever variable you're solving for, you've got to find the value of whatever it is. So with the first question, it says solve the following one-step equations, and our first equation is 3a equals 15. So that means something multiplied by 3 is equal to 15. So if we divide that 15 by 3, we can get back to what the answer actually is, which is 5. And then if you want to double check it, just put your 5 back into the equation and think, well, does 3 times 5 equal 15? Why, yes, it does. Similarly, next question, something plus 6 equals 11. So the something has to be 5. We'll take the 6 away. Next one, something subtract 7 equals 10. The something has to be 17. We get that by adding the 7 back on. And then for D, something divided by 4 is 5. So that's something. D has to be 20. Okay, those are all one-step equations. They should be hopefully pretty cruisy. Where it gets a little bit less cruisy is with these two-step equations. So with these ones, we look at our first one here as an example. We've got a mystery value, A, and it's been multiplied by 4, and then 3 has been added onto it to give us 19. So sometimes a good way to picture this is to think about what's happened to our variable. Like what has happened to A? What journey has A gone on? It's been multiplied by 4, which gave us 4 times A. And then it had 1 added onto it. Oh, no, it didn't. Sorry. My apologies. It had 3 added onto it, which gave us 4A plus 3. And that was all equal to 19. Okay. So what we can do now, if we reverse adding on 3, the way that we reverse adding on 3 is to take 3 away. Take 3, which would give us 16. And then to reverse multiplying by 4, we'd need to divide by 4, which would get us to 4, aka A equals 4. So a mystery number equals 4. In terms of how you might work it out, that's one way that you can visualize it. Another way that you can visualize it is to first erase everything and then do it like this. So you think to yourself, it's been multiplied by 4, it's had 3 added onto it. I have to reverse it in the, I have to reverse each of my steps. So I'm going to start by taking 3 away. On the left-hand side, if I take 3 away, that 3 just disappears. So I'm just left with 4 times A. On the right-hand side, I'll just get my pen back. On the right-hand side, why is that not working though? That's weird. I can draw everywhere apart from in the spot that I want to draw it. I'll try one more time before I'll just have to go down here. Apologies for that. So I've got 4A on the left. Bloody hell. I mean poo-poo. On the left-hand side, I've got 4A. Then on the right-hand side, I'll also have to take my 3 away from the 19 to give me 16. And then if something times 4 is equal to 16, if I divide by 4, I'll be left with whatever the something is, which we've already figured out from our previous example to be 4. So yeah, that's one way that you could visualize it. Same with this one here. We've got a mystery number plus 3, and then we divide the result by 4 to give us 5. I'm going to undo my divide by 4 by timesing by 4. I've got to do that to both sides. So it's going to give me 20 on the right-hand side. And then if something plus 3 equals 20, the way that we find that something is to take 3 away, which would be 17. And again, if you want to check your answer this way, you can put that 17 back in here to see if it works. 17 plus 3 is 20, and 20 divided by 4 is 5. So that still works. Cool, let's do the next ones a little bit faster. So for this one here, something's been multiplied by 5. 5 was taken away from the answer and it left us with 15. Let's add that 5 back on. So something times 5 is going to be 20. So then we reverse that by dividing by 5. So then the something is going to be equal to 4. They end up being pretty similar to the last, yeah, kind of similar, I guess. All right, next one. D take 2 divided by 9 equals 2. AKA something take away 2 divided by 9 equals 2. Let's reverse that divided by 9 by timesing by 9. So now we've got something take 2 equals 18. All right, so if something take 2 is equal to 18, we've got to plus that 2 back on. To give us that the value of that something, which is 20. Again, you can put it back in at the top to see if it works. 20 take 2 is 18, divide that by 9 gives you 2, so that still works. All right, this time we've got a bit of bracket action happening. For this one, we started with E. We took 3 away, and then the result of that was multiplied by 5 to give 15. So this time we've got to get rid of that multiply by 5 first. We'll do that by dividing by 5. And that's going to leave us with E take 3 is equal to 3, which means that our something has to be 6. And again, we can figure it out by popping it back in there. So 6 take 3 is 3, and then 3 times 5 is 15. So that still works. All right, lovely. Last one. This time we've got a number divided by 5 plus 6 equals 8. Let's get rid of that plus 6 first, because again, you've got to undo everything in the opposite order. So you go backwards. Let's take that 6 away, gives us 2, and then we'll undo dividing by 5 by timesing by 5, which is going to give us 10. And again, let's just try it up here, see if it works. 10 divided by 5 is 2, and 2 plus 6 is 8, so it works. Happy days. Okay, now we're on to some linear graphs. This will be the last handful of questions, I'm pretty sure. How exciting is that? Okay, first one, we're going to complete the table of values for each equation below. Okay, the easiest place to start for these ones is at x equals 0, because no matter what you're multiplying x by, whether it's -2 in this case, whether it's 4, whether it's 5, whatever. And whatever we've got in front of our x, if we multiply it by 0, it's always just going to equal 0. So let's start off with that. So I'm going to say, okay, -2 times x, let's say we'll do it when x equals 0. So -2 times 0 is 0, right? Now if I add 2 onto that, I get 2. Easy enough. Next one, -2 times 1 is -2. and then if I add my 2 onto that, I get 0. Now what you should start to find happens here as well is that the difference between each of the terms in the table, as long as our x value changes by 1, which it is going to, in this test at least anyway, as long as that's changing by 1, the amount that y changes is going to be the same as whatever we're multiplying by up there. But you can do 1 or 2 more just to make sure you've got the pattern all sweet. So negative 2 times 2 is negative 4. Add on 2 to that is going to give you negative 2. Now see that we're decreasing by 2 as we go left to right. So now I'm just going to add in whatever values I've got missing. It means it's going to increase by 2 if we go in the other direction. So let's go 4 and 6. Wonderful. Next one. We'll do the same thing that we did last time. So this time our y value is going to be whatever our x value is, take 3. So hopefully that's nice and easy. Let's do it for when x equals 0. So 1 times 0, or 0 times 1 is 0, and then take 3 from that is negative 3. Cool. 1 take away 3 is negative 2. 2 take away 3, negative 1. 3 take 3, 0. And then going in the other direction as well, negative 1 take 3 is negative 4. Negative 2 take 3 is negative 5. Okay. Oh, I'm not really looking forward to this because I always insist that you guys use rulers, and I can't use a ruler on the tablet screen. So I'm not going to use a ruler, but you have to. Anyway, let's plot and label each of our lines. We'll start with the one at the top. So I might just plot I'll probably plot all of them actually. So we'll go negative 2 for x. I'm going to go across to negative 2 and then up to 6. So let's do a point there. Negative 1 for x and then up to 4. So that's there. 0 and then 2, 1 and then 0, 2 and negative 2, 3 and negative 4. And then you have to use a ruler, but I'm just going to eyeball it as best as I can. Oh, this is really irking me that I don't have a ruler. Doesn't matter. If I'd done it in OneNote, I would have had one, but I did it in Word instead. That's fine. So then label it with your equation. And if you put your arrows on either end, you're saying that the that line for that equation is going to continue forever in each direction. So that's a nice little touch. Okay, now for our next line, let's plot negative 2, negative 5. So negative 2 down to negative 5. And this is going to go across 1, up 1, I would say. So negative 2, negative 4, 0, negative 3, 1, negative 2, 2, negative 1, 3, and 0. And I'm just going to, as neatly as I possibly can, just draw in the rest of the line. Okay, don't forget you have to use a ruler. You're not allowed to have a wobbly line like this, but under the circumstances, it's the best that I can do. Okay, label your line with the equation. Don't forget your arrows. Don't forget your ruler. I know I've said that 10 times, but that's fine. Okay, let's have a look at this next one. Right, find the rule from the table of values below. All right, now the last couple that we did before, jump back up to it weirdly. We had y equals, you might have something like y equals 3x plus 1, or you might have y equals negative 2x, take 2 or whatever. So we've got to come up with a rule that matches that table of values. And there's a couple of things that we need to figure out. So what I'm going to say for this one, the easiest way to do it is probably to have a look at what our change is. So let's look at this one. We're going from negative 3 up to negative 1. So it's increasing by 2. Then let's go up another one. It's increased by 2 again. If we went in the other direction, negative 7 increases to negative 5, 2. Negative 5 increases to negative 3, 2. So we know that for every 1x that we go up, y is increasing by 2. So it's got to be something to do with y is equal to 2x. Because for every 1 that x increases by, y is increasing by 2. It's got to be something to do with 2 times x. But now what we've got to figure out is, well, that's not the rule done. We've got to figure out what we've got to add or subtract to have the equation make sense. But the easiest place to do that is probably right here where x equals 0. So if we try this up here, 2 times 0 is still 0. But now what would we need to do to our expression to make that 0 into a -3? We just have to take 3 away, right? So let's try that for a couple of our other points and make sure that they still work. Let's go 2 times 1 is 2, take 3 is -1. That works. 2 times 2 is 4, take 3 is 1. That works as well. And if it works for a couple that you've tried, it's a pretty good bet that you've got it right. Okay, let's do another one. Now, this one is decreasing by 2 as we go from left to right. So for every change, it's going to decrease by 2. So we know it's got to be something to do with y equals -2x. Now we're going to figure out what we've got a plus or minus to make the expression work. Let's look right here, 0 and 5. So -2 times 0 is 0. What do I need to add or subtract to make that into a 5? I reckon I'm going to have to add 5 to it. Okay, so we know it works for that first point. Let's check some of the other points. -2 times 1 is -2. And if we add 5 to that, we get 3. So that works. -2 times 2 is -4. Add 5 is 1. Cool. So if it works for 3 points, it's a pretty good bet that it's right. Right, now we're on to the last question. Well done for sticking with it for so long. If you're just joining us, hello. Right, you have picked up a summer job changing all the batteries of the calculators in the maths department. Very lucky situation. The maths teachers give you 3 options for how you can get paid. Option number 1, a $100 upfront payment followed by $20 per hour. Nice. Option 2, $40 upfront followed by $40 an hour. Pretty good. And then option 3, $50 an hour with no upfront payment. Okay, we've got to represent the 3 price schemes with 3 equations. We're going to use P for pay and N for number of hours worked. Right, so let's say option 1, our pay is going to be equal to $20 for every hour that we work plus 100 for the upfront payment. Pretty generous if you ask me. Option number 2, the pay is going to be equal to $40 for every hour that we work with a $40 upfront payment as well. And then number 3, that's $50 an hour with no upfront payment, so it's just going to be 50 times the number of hours that you work. Okay, I think that I just straight up refuse to draw these 3 without a ruler, but I'm just going to show you how you might plot, let's say plot the first one at least. So the first one, it's $100 as an upfront payment, and then $20 for the number of hours that you work after that. So let's have a look down here. So we've got $100 just for showing up on the day. So $100 up front. So after 0 hours worked, we're on a pay of $100. It's pretty good. And then that's going to increase by 20 for every hour that you work. So I'm going to go across to 1, as in 1 hour, and then add another 20 to the amount that's paid. I'm going to go across to 2, add on another 20. I'm going to go across to 3, add another 20. Across to 4, add another 20. Across to 5, add another 20. 20 again, 20 again. This is a pretty lucrative day for one lucky student. You know what? Actually, I'm going to try my best to draw them. You must use a ruler. I am being very naughty. Oh, that's actually not too bad. But in all seriousness, make sure you use a ruler on the test. Right, 20n plus 100. Okay, let's do the second one. The next one is $40 an hour with a $40 signing on bonus. So let's start here. So $40 for 0 hours, but now we're going to go up 1, 2, 3, 4 for every hour that we work. It's actually a pretty good deal. 1, 2, 3, 4. Going across again. 1, 2, 3, 4. That's interesting. Up again. 1, 2, 3, 4. 1, 2, 3, 4. So what I'm doing now, for every hour that I'm going across, 1, 2, 3, 4, I'm adding on another $40. 1, 2, 3, 4. Here's a question. If you were getting a $40 sign-on bonus and $40 an hour, would you be getting paid more than your teacher? Leave your guess in the comments below and I will ignore them. Okay, and then the last one. Okay, this is a straight up flat rate of $50 an hour. So I'm going to start at $0. 0 hours equals $0 because there's no signing on bonus this time. But after 1 hour, I'm jumping up to 50. After 2 hours, I'm jumping to 100. 3 to 150. 4 to 200. 5 to 50. 6, 300. 7, 350. Okay, now I don't know if I can draw this all in one. Have I told you guys that you must use a ruler when you're doing your assessment? I'm going to say it every time. You must use a ruler. This particular program doesn't allow me to use one, so I'm not doing it. The alternative would be to just not make it and go back to my Sunday afternoon. So I think I'm doing okay. Right, now then, here's the actual interpretation of the question. By the way, if you use straight lines, it might look a little something like this. So that's like a little bit clearer. It shows the same information, but I thought, in my mind, it's probably useful to show you how it would actually be graphed, you know? Right. Let's have a look. What price scheme should you choose if you expect to work for 2 hours? Okay. You want to choose the one that's the most advantageous to you, right? So after 2 hours, you want to pick the one that gives you the most amount of money, which is that one. And reading off the graph, that is y equals 20 yen plus 100. I'm pretty sure that was option number 1. So you answer here, option 1, and y pays most. Now, which price scheme should you choose if you expect to work for 5 hours? Same sort of deal again. Now we're going to look at that one there. So after 5 hours, I'm reading off 5 off the graph. That line that's going along here, that's going to pay us the most after 5 hours, which is y equals 50 yen. That is option 3. So I'm going to say option 3, option, not option. I'm going to say option 3 because it pays the most. Okay, wonderful. Don't forget you have to use a ruler. Okay, I think that is it for all the questions. Another thing to keep in mind is that there are more questions or there's more marks at least on the practice test than what there is on the actual test paper itself. What I mean by that is, for example, will you necessarily have to do 6 solving questions? Yeah, maybe, or it might be like, 4. Will you have to do, how many volume questions is that? It's 3? I don't know, it might be like 2 or something instead. Will you have to do 6 finding the area and circumference? Probably not. It might be more like 2 or 3 or 4, something like that. Anyway, the reason that I mentioned that is it's not literally going to be out of like 77 marks or so, but if you want to mark yourself for the practice test, that's how many marks it is out of. Okay, well done for checking your answers, etc. If you've got any questions, check in with your teacher. All the best and good luck.